In this video, I will go over the homework that follows the lecture on geometric series. And as always, I hope that you watched this lecture. And let's go ahead and jump right into the homework. And the first question is asking to determine the convergence of the given series. And here's the series. And this section is dedicated to geometric series, and we know that geometric series converges to 1 over, or rather b over 1 minus r, when r is less than 1, or between -1 and 1. So this is what we know. So for this series we need to identify b and r, and b is the first term. So to find b, we're simply going to plug in n equals 1 into the general formula, and b is equal to e squared. Now to find r, there are multiple ways to find b and r. So let me show you one and then I'll show you the other way. So this is like the first approach. I'll show you the alternative approach later. Now, your b is pretty much your first term. Now, if you want to find r, so let's just plug in n equals 2. And what do we get? We get e to the 4, 13 to the power -1. Now, if you want to find r is just the ratio between the two terms. So take your b2 divided by b1, and that's going to be your r. So here we see how things cancel out, and that's your r. Now e squared is definitely less than 9, so this is definitely less than 1. So this series definitely converges, and if it converges, it has to converge to b, which is e squared divided by 1 minus e squared over 13. That's the formula. And here we're asked to provide the exact answer. So after we simplify everything, so we may have to multiply everything by 13 and divide by e squared. So here we have, or maybe we're not going to divide by e squared, so we'll just keep e squared. 13 minus e squared, that's the answer. Now, this answer will be the same regardless of how you found your b and r, but let me show you the alternative way to find b and r. Alternatively, we can look at this expression and recognize that it can be rewritten in the following way. We have 13, which we're going to pull out, or not, but hold on, give me a second. So we're trying to express this in this form. That's what we're trying to do, and by doing that we can identify b and r. So if we want n to be n minus 1, then we have to do this. We already have 13 to the power n minus 1, but we have e squared to the power n, and we can easily make it n minus 1. We just have to multiply by an extra e squared over here. So when we do that, we end up with the following expression. So we have e squared, and now e squared and 13 can be combined under the same power, and this is your B, and this is your R, which are exactly the same as we found earlier. So choose your favorite method and stick with it. Both methods are equally powerful. However, we kind of skipped the step of figuring out whether it is a geometric series or not, and assumed that it was a geometric series. But normally you would have to put some effort into figuring out whether you have a geometric series or not. Now the only difference is that Newton calls the first term A, I call it B. Not sure why. Here we have some geometric series, and again, to find the common ratio, you can take your B2 and divide it by B1, or you can take your B3 and divide it by B2, or you can take your B100 and divide it by B99. It just doesn't matter. That's what makes it a geometric series. So let's take B2 and divide it by B1. So we have 128 over 9 divided by negative 16 over 3. So we have 128 times 3 divided by 16 times 9. 16 goes into 128 8 times, 3 goes into 9 3 times, and we also have negative, so the answer is negative 8/3. Now let's just take B5. Actually, let's well, I'll use technology. B5 over B4, 65536 divided by 243, and all that divided by B4, 8192 divided by 81, and I'll just put this in Desmos. We have negative 65536 divided by 243 divided by 8192 divided by 81, and that's exactly the same as negative 8/3. So that's our R. So the answer is negative 8/3. Now, that's an interesting question. Sine of 20 degrees, that's just a number, so don't let that confuse you. So we have sine of 20 degrees raised to the power n, and we know that a geometric series, which is in this form, converges to but b over 1 minus r when r is less than 1. So I'm not sure what sine of 20 degrees is, but it has to be between -1 and 1. So this series converges. So this is like a good true-false question for calculus AP exam or something like that. In this question, we are asked to identify whether this is a geometric series or not, and geometric series looks like this. And we can try, but there's no way we'll be able to get rid of that n from inside of this power. So r here must be a constant, and it seems like we cannot make it a constant. It always depends on n. So because of this, I would conclude that this is not a geometric series. And this is it. If you have any questions, please let me know.